Hello geometry students, this is Mr. Luya, and in this video we're going to cover section 10.5a, secant lines and segments, and specifically what happens with the arc and their angle measures. So, I think by now we're all pretty familiar with what a chord is, a secant line is, and a tangent line is. And the thing is, those are essentially just lines near a circle, and what happens when two of those lines intersect. So, kind of like it says here in the directions, it says that they could intersect in one of three ways. First way is when it's inside of the circle. So you'll see right there that the two lines are intersecting inside of the circle. Another way is on the circle, which is right there on the very edge of the circle, not necessarily inside or outside. And then the last is outside of the circle. So what happens with these angle measures, right? Like angle 1 and angle 2 here, or in this case we're calling the one for outside the circle angle A. So what happens in scenarios like that? So I think the trick here is to figure out which arcs actually connect with those kinds of intersections. So if we look, if we look over here where it says the intersection is inside of the circle, the arcs that kind of connect to that intersection is this arc AD and this arc BC for angle 1. Okay? So that's how we're going to go ahead and decide what equation we're going to write for that. So the formula is pretty simple. It's just simply going to be that angle 1 is equal to 1/2 times the measure of arc AD plus the measure of arc BC. Okay, let me zoom in a little bit on there. All right. And then likewise, if I wanted to think about what angle 2 is, or what the measure of angle 2 is, well, I got to look to see, well, what arcs are connected to that, and that would be arc AB and DC. So we know that angle 2 is 1/2 times the measure of arc AB plus the measure of arc DC. So it's essentially just, the measure of the angle is essentially just the average of the two arcs that are connected to it. Okay? So not so bad, not so bad. Now, whenever I want to think about what happens with the intersection that is on the circle, well, again, I'm going to look to see what arc kind of connects with this angle. So I'm going to focus on angle 1 here first. And the arc that connects to that is pretty much arc AB. And this is actually very similar to what we did in one of the previous sections about inscribed angles. Arc AB essentially is going to be double the value of whatever angle 1 is, or for the purposes of this formula, angle 1 is going to be equal to 1/2 of the measure of arc AB, right there. Okay? Likewise, if I wanted to think about the measure of angle 2, well, the arc that's connected to that one is arc ACB, the larger arc right there. And just like before with inscribed angles, the measure of angle 2 is going to be 1/2 times the measure of arc ACB. Okay? Now, if I look at the intersection that's outside of the circle, so here you'll notice that you have two arcs that are kind of connected to that angle, and the arcs that we're really going to be focusing on are the arcs right there that kind of face that angle. So we have like this inside arc and this outside arc. All right. So essentially, the formula that you're gonna write for this one, for angle A, it's going to be 1/2 times the measure of the outside arc, or of the larger arc, I would say. So CE minus the measure of the little arc, BD. All right, so that's a good way of remembering it. 1/2 times the measure of the big arc minus the measure of the little arc. And I'll be honest with you guys, this is part of the reason. Now, I mean, like if you look at each individual formula, it's not very difficult. But what makes circles a very difficult chapter is knowing when to use the formula, when to use the formula, and just all of the different formulas that you have to remember. Right here, we're teaching you 3 formulas in just this section alone. In the next section, you're going to learn another 3 formulas, and it's just a whole bunch of rules to remember for circles, which is what makes it a nightmare for students. However, we're going to try our best to give you guys as many practice problems as possible so that you can tackle these during the FSA and know exactly what to do when you see a circle. So let's go ahead and go over 3 simple examples here for you. If you look at example 1, it says find the measure of angle STR. So which one is STR? So I know S is right here, T and R. So that angle is STR. And what you'll notice is, okay, well, I know the first thing I'm going to ask myself is, where is this intersection even located? It's located inside of the circle. So let me go ahead and pay attention to the arcs that are connected to that. I have this arc PQ that's connected to it, and I also have arc SR that's connected to that as well. So again, for good practice, I know some of you might want to do this in your head and say, oh, well, it's just going to be the average of both of those 2 angles. Let me just take my advice on this. Start setting it up with the formula, okay? Because if you try to do, try to take all of these shortcuts and these quick calculations, it's not going to help you set it up later when there's actually algebraic expressions with this. So I'm going to think about it and say, okay, well, I know that the measure of angle STR is simply going to be equal to 1/2 times the addition of both of those arcs, 186 plus 112. Okay, so it's going to be 1/2 times, and I probably should have grabbed my calculator. Let me do that right now real quickly. There we go. So my calculator, so 186 plus 112. I shamefully don't want to do that in my head, but that's okay. 298 divided by 2 is going to be 149 degrees. Okay? Now, if I look at example 2, it says find the measure of angle DBC. So from D to B to C. So again, this is an intersection that's on the circle. Okay? So when I think about the intersection that's on the circle, if I want to know what is the measure of that angle right there, I probably would like to know what is the measure of the arc that connects to that. Okay, probably should have used a different color for that. The arc that's connected to that. So I don't really know what the measure of this arc is, or so if I don't know that, how am I going to know the measure of the angle? Well, luckily I should remember that an entire circle is 360 degrees, but if I have that part of the circle, I can go ahead and subtract that from 360. So let me go ahead and go back to my pen. So I know that this arc right here is 360 minus that value of 192, and again, I shamefully don't want to do this in my head, but I know it's 168 degrees. So hopefully you remember from this example above that if you have an intersection that's on the circle, then the angle measure is half of the value of the arc that it's connected to. So I know right now that the measure of angle D, that's not D, that's a B, DBC is equal to 1/2 times 168. And if I multiply that by 1/2, I pretty much get 84 degrees. All right, and then finally, I'm looking at this example right here for example 3. Notice that the intersection is outside of the circle, so I'm going to pay close attention to what the intersections are, or what the arcs that are connected to that angle are. So I'm looking at angle BD, and then I'm looking at angle AE. Now, unfortunately, I don't have the measure of angle BD, but I do have this one. So now you got to be a little bit strategic here and start thinking about other properties of circles, right? So let's see, how can I even use this to figure that out? Well, one thing I can notice is that if I have a straight line right here, well, I know that a straight line measures 180 degrees, and if that's crossing the center of the circle, then I pretty much have a central angle connected to both this arc, which is also 180 degrees, or better yet, I know that this arc right here, it's a little crooked, but you get the point, that arc right there is 180 degrees as well. So if I have these 2 angles, but I have one missing angle, I could just subtract those from 180 and get that. So I know that the measure of angle BD is just going to be 180 minus those 2 angles, so 67 minus 94, and then I get minus 67 minus 94 is just going to be 19 degrees. So perfect. I know that this arc measure, why is it switching to the eraser? That this arc measure is 19 right there. So now I can set up the angle, what I'm trying to find. So I'm ultimately trying to find angle BCD. So I know that the measure of angle BCD is simply going to be 1/2 times the big arc, 67, minus the little arc, 19. So 1/2 times 67 minus 19 is 48. And then that all equals 24 degrees. So right there, I wanted to go ahead, we wanted to start this off by giving you 3 simple examples of how to do all of this. Now, again, it's just a matter of remembering what formulas you have to do. So I'm just going to recap this. If you're looking inside, if the intersection is inside of the circle, you are adding the arcs connected to it and multiplying it by 1/2. And I'm going to jump to the outside, but if the intersection is outside of the circle, then you are subtracting the 2 arcs and then multiplying it by 1/2. And then finally, if your intersection is on the circle, you treat it like an inscribed angle. The connecting arc is simply 1/2, the angle is 1/2 of the value of the connecting arc. All right, so try to keep that in mind whenever you are trying to remember these formulas. All right, so obviously we're not done. We're going to have a lot more examples here, and these examples can get pretty lengthy. So I hope you're ready to sit down for another 10 or 15 minutes for this. So it says over here, for example, 4, if the measure of CB, so let me go ahead and start filling this out. So I know that the measure of CB, so CB is 5x plus 41. The measure of AD is 7x minus 19. And then it says over here that the measure of angle AED is 89 degrees. So from A to E to D, this is 89 degrees. And they want to know what is the measure of arc AD. So this is really the one that they're trying to figure out. All right, so again, as long as you paid attention and pay attention to where the intersection is located, setting up this formula can be fairly simple if you just set it up correctly. So you know that the angle 89. So I'm going to go ahead and say, so I know that the angle 89 is equal to 1/2 of the measure of both of the arcs intersected together added, right? So I'm going to do 7x minus 19, and then plus the other arc, 5x plus 41. Okay? Now, here, I mean, sure, there's a few different ways that you can address, solve this algebraically, and a lot of students might want to, multiply everything by 1/2 or do all of that. Me personally, I'm just going to go ahead and multiply both sides of the equation by 2. That's always a good trick to get rid of that fraction. If you multiply everything by whatever the common denominator is, then all of those fractions will cancel out, and you don't have to worry about that anymore. So now I know that 2 times 89, that's 178. And that's equal to, now that I don't have the fraction here to worry about, I can go ahead and combine my like terms. I have 7x and 5x. That combines to become 12x. And then negative 19 and plus 41 gives us plus 22. And now this is just a simple algebra problem. Let's subtract 22 from both sides. Okay. And that gives us 156 is equal to 12x. And then finally I'm going to divide both sides by 12. And then I get x is equal to 13. So they wanted to know, so now that we know what the x value is, we can finally answer the question, what is the measure of arc AD? So I'm just going to say the measure of arc AD is simply going to be 7x, but now we know that x is 13, minus 19. So 7 times 13 minus 19 is going to be 72 degrees. And there's our answer. So again, really the only difficult part about this was the actual setup. And of course the setup, we wouldn't know what to do unless we know what type of intersection is in that circle. So let's look at example 5 now. It says over here that the measure of angle TSV, so let me get my pen again. So the measure of TSV, this angle is 6x plus 17. And then they say that SV, or arc SV, so this arc, let me go ahead and choose a different color. Arc SV is equal to 15x plus 13. Find the measure of of arc SUV. So really what they want to know is what is the measure of arc SUV. Well, that's nice. It's not even connected to the two things that have values for it, but that's okay. As long as we know what this arc is, then we should be good to go. So let's go ahead and set up our formula based off of this. So one of the things I'm going to note is that the intersection is on the circle. So that should already help me figure out how I'm going to set up the formula. So I know that this angle, 6x plus 17, is going to equal 1/2 of the measure of the arc. And now I know that that arc is 15x plus 13. Okay, so again, I don't know about you guys, but I do not want to deal with this fraction right here. So I'm going to multiply both sides by that common denominator of 2. And luckily, the 2 cancels out with the 1/2 nicely. And so now the thing is, if I'm going to multiply this side by 2, hopefully you remember that you have to multiply it to both terms. So just to kind of help me out, I'm going to go ahead or help me remember that, I'm going to put that in parentheses. So when I multiply both of those by 2, I end up with 12x plus 34. And that's equal to, and now that the 2 and 1/2 canceled, I have 15x plus 13. So now this is no longer geometry, now we're just doing algebra. I'm going to move my 12x to that side so I only deal with positive numbers. So subtract 12x, subtract 13 at the same time. I end up with 21 is equal to 3x. Divide both sides by 3. And then finally x is equal to 7. So they're not asking for x, they're of course asking for angle SUV, and we can only figure out what angle SUV is when we know what the other arc is. And I keep saying angle, I mean to say arc, I apologize for that. So it's going to be 15 times 7 plus 13. So what does that even equal? 15 times 7 plus 13 is 118. So again, hopefully you remember that the measure of the entire distance around the circle is 360 degrees. So if I want to know what is the measure of arc SUV, the measure of arc SUV is going to be 360 minus 118, and that is going to be 242 degrees. All right, so we're almost there, guys. But let's look at example 6. So they tell us that the measure of arc QTS, so QTS, so this whole arc right there, that was poorly drawn. Let me try again. That's still kind of crooked, but that's fine. I'll live with myself. This is 16x plus 23. And then the measure of arc QS, so from Q to S, this has a measure of 7x plus 15. And then finally, the last bit of information that they gave us is that angle QRS, so QRS, this is 5x minus 3. All right, so again, the thing we have to notice here is that the intersection is outside of the circle in this case. So if it's outside of the circle, the setup, you got to remember, you're going to subtract the value of the big arc minus the little arc. So we know that our angle on the outside, 5x minus 3, is simply going to be equal to 1/2 times the big arc, which we know is, you know what, I'm going to use, since I'm going to have parentheses within parentheses, I'd rather use a bracket for the outside. So it's going to be 1/2 times the big arc, which is 16x plus 23, minus the little arc, which we know is 7x plus 15. And then we go ahead and work this out. Again, just like before, I do not want to deal with fractions, so I'm going to multiply both sides by 2. And I'm going to put that in parentheses to remind me to distribute that. And so this 2 cancels out with that 1/2. And now I can go ahead and keep working. So I'm going to multiply the 2 into both of those. So I have 10x minus 6 is equal to, and then I have 16x and 7x. That combines to give us 9x. And then 23 minus 15, so the minus distributes to both, is going to give us positive 8. So now I'm going to subtract 9x from both sides. At the same time, I'll add 6 to both sides. And it works out to be x is equal to 14. All right. So they want to know the measure of QTS. Well, I know that the measure of arc QT. Why did I put A? That the measure of arc QTS is going to be 6. So we know that that's 16x plus 23. So 16 times not x anymore. We know is 14 plus 23. And let's see what that gives us. Plus 23 is 247. All right. Yes, this was a very long section. It is a lot to sink in. But again, as long as you kind of just keep those phrases in mind, if the intersection is inside of the circle, add the connecting arcs, multiply it by 1/2. If it's outside of the circle, subtract the connecting arcs, multiply it by 1/2. And if it's on the circle, you treat it like an inscribed angle, and the connecting arc is double the value of the angle, or you can think of it as the angle is half the measure of the connecting arc. So keep that in mind. Write these on a formula sheet, put them on index cards if it'll help. Do whatever you have to remember all of these properties. I'm going to end it right there. If you have any questions, of course, you can ask any of your geometry teachers. All of us know what we're doing. At least we like to say we do. At least I like to say I do. And then, yeah, just good luck and have fun with the practice.